Hello, geometry students. I'm homesick today, so I'm just going to make you this video. Hopefully this will work for you. Today we're going to be looking at another way to show that two triangles are similar. Two more ways. One's side, 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 and the other one's side, angle, side. Just so you remember, there were two theorems that showed that triangles were congruent by side, 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 and we could look at that, or side, angle, side. And the important thing with side, angle, side is that the angle is included between the two known sides. So we'll kind of look at those two theorems today as they relate to similarity theorems. So I will prove triangles are similar by SSS and SAS, similarity theorems. Okay, now just to get a preview of the side, 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 I'm just going to look at this really quick. Now, one thing we've done is we've looked at the three angles. If two of the angles are congruent to these two angles, then we know they're similar by AA. But we're going to be looking at their sides. So we know all the sides of both triangles. If I did look at a scale factor possibly for this one going from here to here, I would say, okay, well, let's see. If I took my small side like this one, it would be 2/6, which equals 1/3. If I looked at my medium-sized ones, which would be 9 and 3, that equals 3/9, which is also 1/3. And the third side, the 4 and the 12, that would be 4/12, which equals 1/3. Notice that these are all the same, and these are the scale factors. Now, when we do this, we could show that the scale factors are all the same, and then we know that this is similar by side, 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 because we checked all three sides. What turns out to be a little bit easier to do is to say, oh yeah, well, what if I did just take this triangle and I created a smaller version of the triangle by shrinking it down? This is like shrink it down. And what I'm going to do is I'm just going to divide this one by a number that goes into all of these, which is 3. If I divide all of these by 3, then 9 divided by 3 is 3, 6 divided by 3 is 2, and 12 divided by 3 is 4. And we can see now that these two triangles have the same ratio of sides. So we'd say the extended ratio 2 to 3 to 4 is equal to the extended ratio here 2 to 3 to 4. Now this is using what we call the extended ratio. Extended ratio is just a ratio with 3 numbers instead of 2. So this tends to be a little easier, and I'll show you an example with that. Okay, back to this side, side, side similarity. If the corresponding sides of two triangles are proportional, then the triangles are similar. And there's two ways to show this. One is looking at the scale factor. If I wrote the scale factor K for these two triangles, it would be, say, AB over BC would equal AB over RT, sorry, RT equals BC over ST, which equals AC over RS. So that scale factors would all be the same. If I use what's called the extended ratio, I would say that these ratios, AB to BC to AC, would equal the other extended ratio of RT to ST to RS. And those look kind of similar. Those are just the numerators, and those are just the denominators. But that's what we'll look at. So if we look at this first example, we would say, okay, let's see about these three triangles. Now, writing the scale factors is a little bit cumbersome, so I'm going to just look at the extended ratios, and maybe I'll look at these three numbers here, and I'm going to divide them, maybe all of these by the same number, 8, 12, 16. Looks like it could divide by 4. So if I divide by 4 on this one, I get 2, and I get 3, and I get 4. So my extended ratio is 2, 3, 4. If I look at these three numbers, 6, 9, and 12, it looks like I could divide them all by 3. So this kind of works if everything can be reduced down. And so this 6 would become 2. Divide 9 by 3, I get 3, and this one would be 4. So my extended ratio is 2 to 3 to 4. Okay, well, actually, those are the same. Let's take a look at this third one. If I look at this, divide it by, I could divide it by 2, because 10 is divisible by 2 and 5, but 5 doesn't go into those, so I can only divide this by 2. And then I would get 5 and 4 and 8. 16 divided by 2 is 8. So that's 5, or 4 to 5 to 8. So this one is not going to work, but these two are equal. So now I can say that triangle ABC is similar to the other triangle, the one right here. Now, to see what corresponds with A, I'm going to look at my numbers 2 and 3 and say, where's 2 and 3 here? There's 2 and 3. So I have to say this would start with F. And then if I look at B over here, it's in between the 3 and the 4. And if I look at 3 and 4 here, I have D. And then E would come next. So I could get those correspondences correct. Like that. My scale factor for this triangle, just not to be confused, I use my original numbers. Let's say those two short sides, the 8, and this was a 6. So it would be like, say, 6 over 8, which equals 3/4. Okay, and that should be the same for all of them, but I don't have to check them out. But I'm just going to look at the scale factor for these. All right, well, that's how you do it. Let's take a look to below, the guide of practice, just to see this problem once again. Excuse me. I have these three triangles, and I have to see if I can reduce them down to the same scale factor. So if I'm looking at 20, 26, and 24, maybe I'll look at the 26, because that's only 2 times 13. So I can only divide this one by 2, because 13 certainly doesn't go into those. So that would leave this one as 13, divide that by 2 is 10, and divide by 2 is 12. Okay, I'm not going to write the scale factors. I'm just going to divide them up. I'm going to divide this one by the same number. And it looks like, well, 33, I could divide by 3 and 11. So maybe I'll divide this one by 3. And that would be 11, 10, and divide by 3 is 8. It's looking like those numbers aren't the same. Let's just take a look at this one. 39, 36, 30. I could divide these by 3 as well. And that would be 39 divided by 3 is 13. 36, this is 12. And this divided by 3 is 10. And those three numbers look the same as these three numbers. So let's write these out. 10, 12, 13. And this one, 10, 12, 13. So I know these are my similar triangles. Let's look in between 12 and 13, those longest sides. And so let's make sure we got these right. Those are correspond. And then over here, if I look between, say, 10 and 12, 10 and 12 would be this one, and those would correspond. So if I said triangle LMN, I would have to say triangle Y. It's 2 marks. Z. X. If I wanted to find the scale factor, I'll just write it here. The scale factor, remember, I would take a ratio of the corresponding sides. So looking at the side with the 10, the smallest side, I have 30 and 20. The scale factor could be 30 over 20 or 3 over 2. All right, I think that's kind of a long video, so I'm going to stop there and see if I could get that on Google Classroom. All right, and then hopefully there'll be another video for the other side.